Hey guys, welcome back to Voltage Learning. In this circuit, we're asked to calculate the equivalent resistance looking at the terminals of a multi-branch network. So while this might seem a little daunting, it's pretty easy if we go through the problem step by step. So let's get started. First, in step 1, it's important that we work backwards. Let's look at the bottom right. R5 and R6 look like they're in series, the 200 ohms each. So we can combine them directly because they're in series. 200 plus 200 equals 400 ohms. Now in step 2, it looks like that 400 ohms from step 1 is going to be in parallel with R4. So using the reciprocal formula, we can find R456, which equals 133.33 ohms. Now let's keep moving left in step 3. In this case, R3 is going to be in series with R456 from step 2. Therefore, R3456 equals R3 plus R456. 200 plus 133.33 equals 333.33 ohms. Now we're getting a little closer to the end. In step 4, it's important to understand that R2 is in parallel with what we calculated in R3, R3456. In this case, again, we use the reciprocal formula because it's parallel. So R23456 equals 1 over 200 plus 1 over 333.33, all inverted because of the reciprocal formula, is 125 ohms, which is a pretty nice looking number. Finally, here's the last step. We need to add R23456 in R1, which is in series. So R12346 is going to be equal to R equivalent resistance, the total equivalent resistance of the circuit, meaning 125 plus 200, which is R1, is 325 ohms, which happens to be our final answer. So we've taken a complicated circuit with 6 resistors and condensed it down into 5 simple steps of adding in series or parallel. It's important to understand that working backwards in situations and problems like this can really help us break down the question. So if you want more circuits help or tutoring, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.